Welcome to Daily Conversation. This is Mr. K.
This is Eric.
Yeah, today is the 20th of November 2021, and the time now is 6:16 a.m. Well, today is a reading session, and we are going to continue reading the book Eat to Beat Disease. So before we get started, please click the like button and subscribe to our YouTube channel. All right, so here we go. Chapter 4, DNA Protection. Picture your DNA as your personal genetic blueprint, twisted into the shape of a spiral staircase called a double helix, and miniaturized, miniaturized to fit inside a cell. The staircase is made up of genes you inherited from your parents. This is the source code that every aspect of your health depends upon to keep you alive and able to function normally. Yet, DNA is quite fragile and is the target of vicious attacks throughout your life.
Your DNA sustains more than 10,000 naturally occurring damaging events every single day. Some of the errors are spontaneous breaks that occur as a matter of chance when trillions of cells are working and replicating non-stop, day in and day out. Other errors are the side effect of something disruptive that's happening within the body, like inflammation or an infection. And still others are the result of toxic chemicals in the air we breathe, in the foods we swallow, and otherwise absorb through our skin from household products and other environmental sources. However that happens, each error has the potential for derailing our DNA and wreaking havoc on our health. Given this daily onslaught of DNA damage, you might wonder why we don't get sick more often, become mutant, and form deadly cancers every day. It's because our DNA is hardwired to defend and protect itself and thus our health against the consequences of this damage.
Okay, so the fifth line from the bottom, yeah, this one is, uh, where is it? It is havoc, and you pronounce as havoc.
Perfect.
Much of what you hear about DNA day to day concerns ancestry, but they are important breakthroughs for genetic screening that aid in detecting your personal risk for hereditary, hereditary cancers and other diseases. Genomic testing is also being used to guide cancer therapy in the new era of personalized medicine. You may also have heard about technologies that can be used to edit DNA and replace defective genes with healthy ones. But the most amazing stories of DNA is the one I'm about to tell you, how it works as one of our health defense systems.
When our DNA is damaged for any reason, errors can occur in the way out in the way our genetic instructions are followed in the body. When mutations in our genes are inherited, disastrous diseases can result. As we age, our DNA becomes worn down. As we go through life, the choices we make, where we live, where we eat, what we eat, our lifestyle, either help or hurt our DNA. Protecting our DNA is critical if we want to be healthy. When the human genetic code works perfectly, we are in good health. When it breaks down or mutates, our health is threatened.
Our DNA uses distinct mechanism to protect itself. Our cells have evolved with powerful repair processes that constantly monitor our DNA for structural abnormalities. If any are spotted, the repair crew reveals the multiple sets of identical information encoded by the DNA. The damaged sections of DNA are clipped out by molecular scissors in our cells and swept out with the correct structure and sequence. This prevents the vast majority of abnormalities that might develop on our DNA from being passed on when the DNA replicates itself.
Another way the DNA defense system works is through a response called epigenetic change. This allows DNA to react to environmental and lifestyle exposures, including diet, by amplifying helpful genes and blocking detrimental ones. This makes certain genes more or less available depending on the circumstances.
Telomeres are another key to protecting DNA. Telomeres are like athletes, the caps that cover the tips of shoelace, sitting at both ends of your chromosomes. They showed your DNA from the wear and tear as you age. A good diet, quality sleep, regular exercise, and other healthy activities can protect your telomeres.
The third line, the second word, this one I think you pronounce shout, you pronounce shoot.
Oh, yeah.
Is
So,
it?
short, short. Mm,
Is it? You want to check?
uh,
I also not
yeah,
sure.
yeah. I'm checking.
Shield.
Shield. Yeah, should be shield.
Shield.
Mm. Diet plays an important role in optimizing the power of these DNA protection systems. In part 2, I will share details on which foods have been discovered to support DNA repair, which one cause help promoting epigenetic changes, and which protect and even enhance telomeres. Along with the modern progress being made when genomic testing, gene editing, and gene therapy, we are beginning to decipher how diet impacts our DNA health defense system. To see how far we've come and understand the role of diet, it's helpful to look back briefly at the origin story of DNA research.
A history of DNA. Even though grade school children now learn about DNA, Remarkably, we've known about DNA for only about 150 years and cracked its code in the last 50. The study of inheritance is traced back a scientist and Augustinian fri- friar from a town called Brno in Moravia, now Czech Republic. His name was Gregor Mendel. Mendel noticed that peas growing in his garden can be crossbred in combinations to achieve certain traits, such as color and shape. In 1866, he published his research showing there were certain rules that apply to the passage of traits from one generation to the next. These are called the rules of Mendelian, Mendelian inheritance, and Mendel speculated that some invisible factors, genes, carried the information that would determine the traits of any organism.
The first actual physical evidence for DNA was discovered in 1869 by Friedrich Mierschert, a doctor conducting research in Tübingen, Germany. Mierschert was examining wounds pools taken from the bandages of soldiers injured in Crimean War. He found some unusual material that he believed came from the inside of cells. He named it nuclein. 12 years later, in 1881, Mierschert, former professor, the German biochemist Albert Courcelle, felt it would examine the findings more closely. Courcelle worked out that nuclein was made of deoxyribonucleic acids and coined the term DNA. In 1910, this discovery won him the first of several Nobel Prizes given for research on DNA.
Okay, the third line, the fourth words. Yeah, this one should be pass and you pronounce as puss.
Pass.
The true nature of DNA, however, remained a black box mystery for another 71 years. Then, in 1952, the first high-resolution pictures of DNA were taken by Rosalind Franklin, working at King's College in London. Guided by the images, James Watson and Francis Crick worked out the structure of DNA the following years at Cambridge University, effectively cracking the code of life for which they received the second Nobel Prize for DNA in 1962. After this, tens of thousands of scientists rushed into the field of DNA research to unlock the secrets of the source code that makes us human.
In 1990s, one of the most ambitious scientific undertakings in all of human history began, the Human Genome Project. The goal of this massive undertaking, which involved more than more than 20 universities across the United States, France, Germany, Spain, United Kingdom, China, and Japan, as well as the National Institutes of Health and a private company called Genomics, was to map out every gene in the human body. On April 14, 2003, beating its own 15th-year deadline by 2 years, the US government announced that the entire human genome had been officially sequenced. This milestone achievement was led by two pioneering scientists, Francis Collins and Fred Venter. Since then, the complete sequencing of the genome has gone beyond humans to include other species, including chimpanzees, dogs, mice, and even frogs.
Yeah, the second line from the bottom, the fourth words. Yeah, this one is genome. We pronounce as genome.
Genome.
The science of DNA. The source code of DNA is written in chemicals with names that begin with one of four letters: A, adenine; T, thymine; C, cytosine; or G, guanine. The steps of spiral staircase are made of different combinations of pairings of these letters, AT and CG. A sequence of these pairings that encodes instruction for a complete protein is known as a gene, which would be akin to a group of steps on the spiral staircase. Collectively, your genes spell out the instructions needed to make the 10,000 proteins your body needs to stay alive.
Amazingly, every cell in the body knows how to read this source code. Cells use this code by downloading it into cellular machinery that acts like a miniature 3D printer, manufacturing proteins based on the code. The production of these proteins happens behind the scenes, silently, every single second of your life, from the moment you conceive until the moment you die. When you hear the term human genome, when you hear the term human genome, is referring to the complete collections of genes made up of DNA as a required code for what your body needs over the course of your life.
To set the stage for how the genome stays healthy, first, consider the mind-blowing amount of DNA inside your body. Each cell contains about 6 feet of DNA spooled into coils that form tight packages called chromosomes. Chromosomes, of which each cell has 46 inside its nucleus, 23 from your mother and 23 from your father. If you were to pull and straighten out the DNA from all of the cells in your body, current estimate is 37.2 trillion cells, and line them up end to end, you'd have a genetic superhighway extending 42 billion miles long. That's the distance from Earth to Pluto, 10 times. times 10. Here's the really interesting thing. Only 3% of this DNA superhighway actually makes up our genes. The other 97% of DNA serves as air traffic control to guide the body on how the genes are used.
Just like at a busy airport, where highly trained operators in air traffic control ensure that planes take off and land safely. Precision in DNA functions is absolutely essential. Errors can have deadly consequences. When the source code is damaged, the 3D printers in your cell can manufacture too much of harmful proteins or too little of useful ones, or even make the wrong protein altogether, or defective ones. These errors can have dire consequences, just like misdirections of air traffic control can lead to near misses, minor accidents, or total annihilations of a plane and his passenger.
Okay, the second line from the bottom, which is the uh, last few words. Yeah, this one is annihilation. We pronounce as annihilation.
Annihilation.
Unfortunately, DNA damage dangerous. Unfortunately, our world is a really dangerous place for DNA. Many external factors pose threats because they can disrupt and damage our source code. Although many dangers are created by industry, not all of the threats are man-made. One of the most harmful factors to DNA is, in fact, ultraviolet radiation. Sunshine. Do you always remember to wear sunscreen when you go outside? Research has shown that the harmful UV radiations from the sun that penetrates our skin is capable of producing 100,000 lesions in our DNA every hour if unshielded. And going indoors after lying out on the beach doesn't mean the assault on your DNA is over. Scientists at Yale University have shown that the damage continues even after sun exposure. The melanin pigment in your skin, which tans you and absorbs radiation, actually stores the energy through a process called chemiexcitation. The pent-up energy is released once you are indoor and it continues to cause mutating DNA damage in skin cells for more than 3 hours, even though you are no longer in the sun and cooling off indoors.
Pain at the feet can be harmful to health, of course, but there are other insidious ways the DNA damaged by the suns. If you have ever sat in traffic on your morning commute with the sun streaming through your windshield, UV radiations was damaging your DNA the entire car ride. Even more invisible is what happens when you fly in an airplane. Do you wear sunscreen every time you get on a flight? You should. A 2015 study by researchers from the University of California, San Francisco, published in the journal JAMA, the The methodology show that pilots flying for just 1 hour at 30,000 feet altitude receive the same amount of UV radiation through the cockpit window as they would from a 20-minute season in a tanning salon. Alternatively, cloudy weather makes things even worse for pilot and passengers. Clouds just reflect the radiations from their tops right back at the airplanes, increasing the risk of DNA damage and melanoma.
Okay, wait a minute. It is okay. The fourth line from the bottom, the last word. Yeah, this is should be session.
Session.
Yeah.
Session.
The sun is not the only threat. Damaging radiation also emanates from the ground. This is in the form of radon, an odorless natural gas that enters homes through basements. Different parts of the earth emit different levels of radon, but it is an invisible home invader that damages DNA. In fact, radon is the number one cause of lung cancer in non-smokers. If you smoke, you shouldn't. The radon you inhale at home amplifies the lung cancer risk caused by cigarettes.
On its own accord, tobacco smoke is toxic to DNA. There are an estimated 4,000 chemicals inhaled in cigarette smoke, of which 70 have been shown to be carcinogenic, including benzene, arsenic, and formaldehyde. There's nothing recreational or harming about inhaling these chemicals. They provoke inflammation throughout your entire body. Even if you are not a smoker, the bad news is that secondhand smoke is equally harmful to the DNA of unwitting friends, family, coworkers, and even pets.
Solvents of gassing from carpets, new cars, and chemicals in ordinary household products like nail polish remover, shampoo, and paint damage DNA too. If you drive a car that uses gasoline, when you fill up the tank, you are breathing in fumes containing benzene, which damages DNA. It is wise to stand upwind of the vapor while you are at the gas station.
Research is revealing that these toxic exposures that damage DNA can even affect future generations. For example, the DNA in a father's sperm can be affected by toxic chemicals like bisphenol A used to make plastic. Diethyl phthalate used to make glow sticks, and cadmium found in ceramic, glasses, and cigarette smoke. These exposures alter the genes in sperm through epigenetic mechanisms, and the alterations can be passed on to his offspring. Similarly, noxious chemicals such as benzene in petroleum, perchlorate used in dry cleaning, and cigarette smoke that a mother may be exposed to during pregnancy can leave its marks on the fetus DNA, which will persist in the child for the rest of its life.
DNA can make you sick or even kill you. But DNA has one prime directive: to be passed on as intact as possible from one generation to the next. To ensure that it is fulfilled this destiny, DNA has defense mechanisms to fight back against harmful exposures. Let's have a look at them, because in Chapter 9, we'll see how these defenses can be powerfully enhanced by what we eat.
The first DNA health defense, DNA repair. The amount of DNA damage that occurs every day is staggering. Our DNA has been hardwired to repair most of the damage before it even becomes a problem. Fewer than one of every 1,000 errors introduced to our DNA are estimated to become permanent mutations, thanks to built-in self-repair enzymes. These enzymes perform an intricate dance at the molecular level as they go to work. Their repair ability is perfectly designed to fix DNA's unique structure.
Okay, the second line from the bottom, which is the sixth word from behind. Yeah, this is molecular, and you
Mol-
pronounce as molecular.
Molecular.
Recall that in every strand of normal DNA, each step of the twisted staircase that makes up the double helix contains two molecules. DNA has a strict rule for how the molecules can be paired. Adenine is always paired with thymine. Cytosine is always paired with guanine. This is called base pairing. Some common forms of DNA damage disrupt these pairings. About 100 times per day in each cell, cytosine spontaneously transformed into a different chemical compound, creating pairings that don't follow the rules. Exposure to solar radiation is another trigger that can cause two thymine molecules to stick together, creating an abnormal set of chemical conjoined twins that can't function normally. Severe damage can also be caused by free radicals. These natural chemicals contain a highly unstable oxygen atom that can release energy into its surrounding like a chemical grenade, damaging the orderly pairing of normal DNA.
Your cells contain repair enzymes that can spot and fix this kind of damage. The enzymes springs into actions when they see deviations from the orderly structure of DNA double helix. When missing or damaged sections of DNA are identified, they are replaced with normal parts, like a tailor repairing a damaged garment. The repair enzymes match the material and seal it in to make it as seamless as possible. The material that's matched in DNA repair is drawn from the nucleoside A, T, C, or G, and they are replaced in the correct order where they belong in the double helix.
Scientific and clinical research has shown that eating certain foods can reduce DNA damage, either by increasing the speed and efficiency of the repair process after damage or by preventing damage in the first place. Antioxidants are often thought of as protectors of DNA, and their benefits have been heavily marketed by the supplement industry. Yes, antioxidants can help prevent damage by neutralizing free radicals that float around in our bloodstream, but they cannot help DNA after the damage has been done. At that point, DNA repair mechanisms are needed. We will explore the foods that influence DNA protection and repair, including new ways to use antioxidants for health in Chapter 9. Yeah, so this is the last line that we read today.
Yeah, summary.
Okay. Yeah, so for today's part, we talk about DNA as a way, as one of the defense system. And DNA protection, yeah, this is the topic today. And it talk about DNA and try to explain what is DNA and how it looks like. And for my understanding, yeah, DNA is something like the shape of DNA is uh, is actually the double helix in a staircase. Yeah, so you can imagine a staircase, and then which is a spiral staircase, and then inside a shell, inside our body cell, and then so this is the DNA, and then yeah, so and then through our lifestyle, let's say our sleep, our diet, and the food, yeah, the food, the air that we breathe in, all of these things can affect DNA. Yeah, and also the DNA will uh, uh, will bring some hereditary uh, diseases. Yeah, and then which means that uh, if we got cancer, and then it will somehow change our DNA, and then this can be it is like recorded in our DNA and can be passed on to the next generation. Yeah, and then by which way I think there is a part talk about as we age, DNA becomes worn down. So maybe this is like if you got cancer, and maybe these kind of things somehow affect the DNA, and the DNA pass on to the next generation, and the DNA in their body will kind of like uh, become damaged when they age. Yeah, so this is one part, and then also I also try to do a quick search about genes and DNA. And genes is the sequence of DNA. So basically, DNA has four source code, which is A, T, C, and G, and they will pair with a particular source code together, and then after they pair, it is called a DNA, and then it is also the double helix. And this kind of DNA, they are kind of the code. They are giving the instruction to our cells, and then our cells will make protein. They will manufacture protein to support our body, used in growth, developments, and many other ways. I believe that also the defense system. Yep, and then yeah, so this kind of pairing is not necessary to be done to be paired perfectly. So it means that once there is some maybe errors, and this kind of pairing can actually create a negative protein to our body. So to some extent, we can say that this kind of genetic code uh, can affect our health. Yeah, if they work well, if they pair correctly, and then it support our healthy body. And if it didn't pair correctly and has got a lot of errors inside, and it actually affects our body in a negative way. And then yeah, even though that could have some damages to the DNA or some errors occurs, but our cells are designed to be able to constantly monitoring DNA. So our cells will also uh, try to repair it if when needed. And then mm, yeah, and then I talk about the DNA damage dangers. Yeah, in that part, I talk about one of the biggest kind of like the biggest killer, yeah, the biggest threats of DNA can be the UV radiations, yeah, which is the sunshine that we will that we will encounter every day. Yeah, so the radiation uh, uh, the effect of radiation, UV radiation, should not be underestimated, and even not from the sunshine directly, it also comes from the ground, which the sunshine goes into the radiations go into the ground, and it will somehow like uh, reflect back, and then which also cause the UV radiation, which is harmful to DNA. And also it lines up, it mentioned the 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 disadvantage of cigarettes, yeah, which also uh, is something harmful to DNA. Yeah, it got a lot of chemicals inside, as well as other products in our daily life, for example, shampoo, and maybe the gasoline, and also some household products, and even some plastic, yeah, that we use. They actually can release those chemicals, and then this kind of chemicals is harmful to our DNA. Yeah, so this is some important thing that I pick up from today's reading part.
Mm. Yeah, I have 3 points. The first is DNA will mutate. Yeah, and DNA mutate will cause cancer.
Mm,
And is the first one. And 3% of DNA is the is a source code uh for the genes, and 97% the remaining 97% is maintaining function and control the body self to follow the source code. Yeah, mm, this is a very important point, and I mean at least to me, because I know that a lot of things in our world is like this. Few of the percentage, maybe single digit of the percentage of the things is the most important things, and you cannot without it. And this is the source code. This is the
mm,
key. Is the core. But if you only have that, it is still not enough. You need to control it. You need to have the disciplines. You need to uh, uh, prevent it mutates, prevent it run out from disciplines. Yeah, and this and you can say this could be one of the universe uh, law or the law of nature, which is the least effort pathway. Yeah, if you try to behave uh, in other way, it will cost you more efforts. Yeah, and this kind of strategy, few percentage is a source code, and the remaining percent help it maintain, keep it disciplines. I would say this is a least effort pathway strategy. And the third point is the radiations hurt DNA. It also causes DNA mutate, and the result is cause cancer, all kind of cancer, not only skin cancer. And it it actually let us know and remind us the importance of wear sunscreen on skin and avoid direct exposures under the sun. Yeah. And what caused the radiations and why we couldn't expose under the sun is caused by the UV ultraviolet radiations. And UV radiations um, not only occurred in the shiny day, it also occurs in the cloudy day. Yeah. So this is the three of the point on to make summary.
mm. Yep, yep. And yeah, you also highlight some of the examples, right? Which is, for example, uh, the UV, and also the benefits of EV, because of the gasoline is something harmful to DNA.
Mm,
Mm, yep, there are some good examples in this reading part.
yeah. Yeah, and also one more thing, which is
Mm,
the chemical plus plastic also hurt our DNA. Mm.
mm,
Mm. So it made uh, so that means the shampoo we are using, the body wash we are using,
mm,
the everything we are using, maybe including the toothpaste, also are hurting our DNA.
mm, yeah,
And also
and
see around ourselves how many plastic you are you are contacting every day.
mm, yeah, my glasses, I'm always
Mm,
wearing it. And
mm,
also, I once saw one of the shampoo that I used in the past. I saw from the package, and it says something like free of benzene. At that time, I don't know the meaning of benzene. Yeah, I thought that is something that will cause maybe pollution to the water. Yeah, but today we came across these words. It is actually also one of the chemical that is damaging our DNA.
mm,
Yeah, and another interesting story I would like to share with you, which is the real story. Uh, I remember one of my friend who actually bought a new car, and then because his car is new at that time, and then every time we uh, get into the car and we can smell the odor of the new car. Yeah, it has got a smell, right? It is a new car. Yeah,
Yeah.
and my friends say it is so enjoying. It is so like happy to s- uh, to 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 smell it. Yeah, and I believe that because nobody know that it is harmful, and if people know, and I don't think they will enjoy it so much.
Mm.
Yeah,
Yeah.
so these are my sharing today.
Okay, so that's all for today's conversations. How do you feel? Did you enjoy the conversations? Please tell us what you think of our conversation. And we are not native speakers if we found any vocabulary mistake that we made. Please also comment to let us know because we want to learn more and improve ourselves. Remember to like subscribe to us. Thanks for watching. See you tomorrow.
See you tomorrow.